Okay, so we're doing this pulsatile flow example, example number 2. Let's read it. For a given graph of flow rate versus time, there's a flow of 0.6 centimeters cubed with each beat of the heart. If there are 2.5 beats per second, what is the maximum flow rate? Okay, so double check. So the plot is making sense. There's no tricks there. It's actually centimeters cubed per second, and we're not using meters per second, meters cubed per second. In this pulsatile flow stuff, it's typically centimeters cubed per second. So centimeters cubed per second, it's plotted in degrees. That's the normal way of plotting time. Sort of weird. Okay, we're going to be working with triangles, and as you can see, that we can have A1. This is A2. And this is A3. And we're going to say that the flow per beat, okay, is going to be equal to area 1 minus area 2 plus area 3. But because these two areas are equal and opposite, we can cancel the second and third in this example. The area of the first triangle is simply, or the first curve is basically a triangle, and it's going to be 1/2 Q peak or max times, let's just call it delta t. And so what's delta t going to be? 1/2 Q peak times 240 degrees minus 0 degrees, I'm spelling it out, and then we have to convert that to time. It's going to be TP over 360 degrees. So the degrees cancel. What's TP? TP, I'm going to do it over here. How do we figure out TP? Did they tell us? TP is the pulse time. And they told us that we had 2.5 beats per second. So we're going to take the ratio of that. TP is equal to 1 over the rate, which is equal to, pull it out, calculator. Okay, and I need the lights on for my cell phone, my solar-powered calculator to work. 1 divided by 2.5 beats is equal to 0.4. So 0.4 seconds per beat. Next, what do we do? So they wanted the peak flow or the beats flow per beat. For a given graph, there's a flow of 0.6 centimeters cubed with each beat. They gave us this one. This is 0.6 centimeters cubed per beat. So we can rearrange. I'm going to rearrange over here. I'm going to finish this problem in this little corner here. Q peak is going to be equal to 2 times Q beat divided by 24 degrees, and then we have 360 degrees divided by 0.4 seconds per beat. Okay? So Q beat was 0.6. That's the only number I didn't put in there. Okay, I'll put it in there now. This 0.6, 240, 360, 0.4. 2 times 0.6 times 360 divided by 240 divided by 0.4 equals 4.5. 4.5, and that's going to be in centimeters cubed per second. Okay, that's the answer. That wasn't so bad.